BJT as a switch, as a switch. Now see, we know our BJT, you have some biasing voltage as VCC, then you have a current IC flowing through RC, then you are taking output from collector only. Okay, please note it down that output in a BJT is generally taken from collector when it is common emitter configuration, and it is taken from emitter when it is a common collector or emitter follower configuration. So this is emitter here and this is base here. This will be RB and this will be V input, and whatever current that will flow through the RB, it will be IB. Okay, IB. Now see here, V output here, V output is taken from collector, V output. If we calculate from this circuit V output will be equal to VCC minus ICRC. V output will be equal to VCC minus ICRC. And if we assume that VI is varied, VI is varied, VI को change किया जा रहा है. So there can be cases like if V input in this circuit is less than VBE. VBE is the cut-in voltage of base emitter junction. Okay, so this is VBE, and if the transistor, if the BJT is made up of silicon, it is equal to 0.7. So it is cut-in voltage. It is cut-in voltage. So first case would be, so case 1, if VI is less than VBE. Now see, if VI is less than VBE, in that case, IB will be equal to 0 because V input is very small than VBE. It is less than V 0.7. So current cannot flow or electrons cannot cross the base emitter junction. So in that case, current cannot flow through the base terminal. So IB will be equal to 0. If IB will be equal to 0, IC will be also equal to 0. IC will be also equal to 0. And what will be V output in that case? V output will be equal to VCC minus ICRC, which is equal to VCC minus 0 RC. So V output is equal to VCC. Okay, V output is equal to VCC. So please note it down. So if input is very small, it is less than VBE, V output will be VCC. Why? Because you have this transistor is off. It is like this. You have V output here. This is VCC. Since the terminal is floating, it is not lashed to ground. So all the voltage will appear across the output terminal. All the voltage will appear across the output terminal. Now second case is that if V input is greater than VBE, that is cut-in voltage, if V input is greater than VBE, if in first case, when V output is VCC, we can say that transistor cannot conduct here. Okay. In second case, if V input is V greater than VBE, transistor can conduct. Transistor begins conduction then. Okay, because it is quite higher than 0.7 conduction. And we can also say that current flows or current flow begins, whichever current is, whether it is base current or it is collector current. If current will flow, we can say that base current will flow. What is base current equal to? It is V input minus VBE divided by RB, by applying the KVL in the input loop. That is quite easy. And if this current increases, it goes on increasing, then it will also increase IC. It will also increase IC because IC is equal to beta times IB. Since IB is increasing, and IC will also increase. IC will also increase. And what will happen to V output because of increase? V output is already equal to VCC minus IC RC. Since this term is increasing, this term is increasing, this term is increasing, it means that V output will overall decrease. V output will overall decrease. Okay. So if V input will increase, IB will increase, then V output will be decreasing. Now if V input is very high, अगर V input बहुत ज़्यादा होगा and current will be very high, IC will be also very high, it will saturate. In that case, the transistor will turn on. Transistor current will be very high and it will be behaving like a short circuit. ठीक है, तो ये short circuit करेगा behave. In that case, if you have VCC here, V output you are taking here, all the voltage VCC will be lashed to ground. So at output you will have ground. So there will be no voltage at the output. If input is very high, if input is very high, अगर इनपुट काफ़ी ज़्यादा हुआ और बेस करंट भी बहुत ज़्यादा उससे होगी, then IC will be very high, IC will be quite high, and it can go to saturation region even. जब IC बहुत ज़्यादा होगी, आउटपुट बहुत कम होगा, तो आउटपुट will be very less. How much less it can be? If current is very high, output can be virtually equal to zero. It will be nearly equal to zero. So in that case now, V output is equal to small, or I can say zero. Okay, if transistor is saturated, अगर हम transistor को कहेंगे, it is saturated. And you also know that in saturation mode, what is VCE equal to? VCE saturation value. 27, what is the value of VCE in saturation mode? What is the value of saturation? 27. 76, what is the value of saturation in VCE? 76 है यहाँ पे?
Yes, sir. Sir,
What is
nearly equal to 0.
nearly equal to 0? Because output characteristics of transistor are IC versus VCE. And when you say saturation mode, it means somewhere here. And when you say VCE saturation का value होता है ये. VCE saturation is nearly equal to 0. It also means that if you have a transistor working in saturation, and this is VCC, and this is your, RB, and this is V input here, and this is V output here, this is RC. So whatever potential is between collector and emitter, so this is VCE. When VCE is nearly equal to 0, it would mean that it is a short circuit. It would mean that it is a short circuit. So when the transistor will be working in saturation mode, VCE will be nearly equal to 0, or we can say that the transistor will behave like a short circuit. And if transistor will behave like a short circuit, V output will be very small. It will be nearly 0. Roll number 38, आपको समझ में आया बेटा ये?
Yes, sir.
So we had like this, the combination V input and V output. When V input was small, and it was less than VBE, output was VCC. It is high. Okay. When V input is large, it is greater than VBE, then V output is small, nearly equal to 0 or low. So we can say that we have a 0 from inside, from input, and you have very high at the output. Then we have a high in the input and you have a low in the output. So When we say that transistor as a switch application, we can remember that BJT acts as an inverted switch. Inverted switch in saturation. Saturation में it acts as an inverted switch or an inverter. Inverter, okay? Inverter or NOT gate. तो क्योंकि हम इसको इनपुट में जब स्मॉल वोल्टेज देते हैं, लो वोल्टेज देते हैं, तो आपको आउटपुट में हाई मिलता है. अब इनपुट में हाई दे दो तो आउटपुट में लो दे देता है. दैट इज जॉब ऑफ एन इन्वर्टर और एन नॉट गेट. So BJT acts as an inverted switch. It can work as an inverted switch. Now, the question is, what is the current that flows when the transistor is acting as a switch, when the BJT is acting as a switch? Okay, so I'll write down few lines here. If we can note down from the above discussion, if V input is gradually increasing, if V input is gradually increasing, then what will happen to VCE? VCE, then VCE is reducing, okay? Then VCE can reduce up to VCE saturation. रोल नंबर 12, आपको बेटा ये समझ में आया?
Yes, sir.
किसी को कोई सवाल तो नहीं है? What I am discussing here, I am discussing BJT as a switch. तो मैंने कहा कि ये ज़्यादातर जब when we want to operate BJT as a switch, we operate it in the saturation region. Why in saturation region? VCE is very small. VCE is very small, and you will get nearly uh, an inverted kind of operation in this BJT. And I also explained if input will be less than VBE and greater than VE, what will be the impact at the output. So I'm just summarizing that if V input is gradually increasing, then VCE can reduce up to VCE saturation, and VCE saturation is the lowest value of VCE. It is the lowest value of VCE. Typically, it is nearly zero. When transistor is in saturation, then VCE is nearly zero, and we can say that transistor acts as a short circuit. So VCE saturation, what is VCE saturation? VCE saturation basically it represents minimum voltage drop between collector and emitter terminal. Collector and emitter terminal due to non-zero internal resistance of BJT. So ideally it should be equal to zero. ये थोड़ा सा zero तो नहीं होता है, it is nearly zero. It should be ideally equal to zero. But since there is a non-zero internal resistance of BJT, that is why some potential drop will be always felt. कुछ potential drop हमेशा होगा वहाँ. तो ऐसा भी नहीं होगा जो ideally it should be zero, it will be zero. It will not be practically zero because there is some non-zero internal resistance of BJT, because of which VCE saturation is observed. Okay. Now see, if VCE becomes equal to VCE saturation, then it cannot decrease further because it is the lowest value. Then it cannot decrease further. That it cannot decrease further. Hence, IC cannot increase further. IC का भी एक पूरा limit पहुंच जाएगा. Okay. IC will be maximum at VCE equal to VCE saturation. Hence, IC cannot increase further. IC cannot increase further. Then BJT is said to be saturated. Then BJT is said to be saturated because IC is not increasing now. Okay, अगर VCE और डिक्रीज नहीं हो पाया तो आईसीई मैक्सिमम ही होगी। अब देखिए, when VC is decreasing, when VC is decreasing, you have basically this kind of transistor. I would like to comment on it. See, the transistor is like this. The transistor is like this. So IC is flowing here in RC. ये जाती तो है कलेक्टर में, फिर आती है वापस एंड निकलती है RC से. When you have some potential drop here, which is V1, and some potential drop here, which is, for example, VCE, and if you are pushing this transistor into saturation and you know that VCE is decreasing, it is further decreasing and going to saturation value. जब ये VCE decrease होता है, इसका मतलब है potential drop across collector to emitter junction is also decreasing. When potential drop across collector to emitter junction is decreasing, it means that resistance is also decreasing. Okay, because V is equal to IR. अब देखिए, V is equal to IR means when V is decreasing, जब potential drop decrease होगा, it means that it is directly proportional to R. तो आपका R decrease होना चाहिए. It means that the resistance, internal resistance between C and E is actually decreasing. When VC is minimum, okay, when VC is minimum, VC is equal to VC saturation. It means that you have the minimum possible resistance in between collector to emitter, beyond which it cannot decrease. And when resistance between collector to emitter is minimum, then you can say that IC is maximum, because when you have less resistance path, more current will flow, more current will flow. So when you have minimum resistance, IC will be maximum. And if you are not able to decrease the resistance between C and E beyond VCE saturation or beyond a certain point, it means that you cannot increase IC further. IC को भी और ज़्यादा नहीं कर सकते हो increase. In other words, we can say IC becomes saturated. IC also becomes saturated. Okay, so that is what I said, that if VCE becomes VCE saturation, then it cannot decrease further. Hence, IC cannot increase further. Then BJT is said to be saturated. BJT is said to be saturated. Okay. 27, is it fine, beta? ठीक है ये?
जी सर.
Okay. So if किसी को कोई सवाल तो नहीं है इस पे? If you have any question, please ask me. Do not hesitate. Okay. So if now we are saying that IC also become saturated. So BJT have now become saturated. BJT have now become saturated. Now see, if when BJT becomes saturated, when BJT becomes saturated, we can say that VCE is also saturated. VCE is constant now. We cannot change it. And how much is that equal to? It is equal to VCE saturation. Although its value is small, but it is constant now. And IC is also constant. IC is also constant. And what is the value of IC? The value of IC is now IC saturation. Okay, IC saturation. And if you are asked to calculate the value of saturation collector current at saturated state, IC saturation can be calculated by applying KVL. Okay, I said that IC saturation, it is equal to, we can, calculate IC saturation by applying KVL in this circuit. इसमें KVL करेंगे apply, it is very basic calculation. I'll just write it down. You can check it at your places. If there is a problem, then you can come to me. So VCC minus, अब VCE नहीं है, we have VCE saturated. We have VCE saturated divided by RC. So this is the saturated value or the saturation value of collector current. If it is asked to calculate the IC saturation, you can also find it by using this relation. So this is the saturated or maximum value of IC. कभी कभार questions में ऐसे भी लिखा होता है, find the maximum value of collector current that can flow through the transistor. It all automatically means find the saturated current that can flow through the transistor. Okay. Now see, If Vi is further increased, then Ic will remain constant. If Vi is further increased, क्योंकि अब ट्रांजिस्टर जो है वो सैचुरेटेड है, करंट तो अब इंक्रीज नहीं होगी. Even if you increase Vi, then Ic remains constant. Okay, Ic remains constant at Ic saturation. इसमें जो मैक्सिमम वैल्यू होगा, अब अगर BJT सैचुरेटेड है, even if you increase input, then Ic will remain saturated at Ic saturation value. But IB keeps increasing. But IB keeps increasing. IB keep. Okay, so please note it down. BJT is working in saturated mode now. अभी BJT जो है, we are assuming that VCE has reached to its limit, VCE saturation, and IC has also reached to its limit, IC saturation. So basically, what we are trying to say is that if I have a transistor like this, and I have RB here and RC here and V output here, the current that flows through RC, it has reached to the limit of IC saturation, and the voltage here, it has reached to the level of VCE saturation. ठीक है, तो ये तो आउटपुट सर्किट पैरामीटर्स हैं, लेकिन इनपुट साइड से वी हैव इनपुट एंड वी हैव IB. इस पे तो हमारा कंट्रोल नहीं है. ऐसा भी पॉसिबिलिटी है दैट V in will further increase, V in will further increase, V in will further increase. ऐसी ऐसी पॉसिबिलिटी है कि आपको एक साइनोसाइडल है सिग्नल इनपुट पे, और इस पॉइंट पे जब वो पहुंची तो आपकी IC पहुंच गई सैचुरेशन लेवल पे, लेकिन फिर भी इनपुट इंक्रीज हो रहा है, क्योंकि उस पर कंट्रोल तो हमारा नहीं है. इफ इनपुट इज फर्दर इंक्रीजिंग, देन IB विल आल्सो फर्दर इंक्रीज, IB विल फर्दर आल्सो इंक्रीज. तो लेकिन उससे कोई इम्पैक्ट आपको कलेक्टर करंट पे नहीं होगा. कलेक्टर करंट विल बी ऑलवेज सैचुरेटेड, इट विल बी मैक्सिमम, it will be maximum. Okay, so it will be maximum. So that is what I am saying here, that but IB, but IB keep IB keeps increasing. Okay, IB keeps increasing, IB keeps increasing, and uh, and since BJT is saturated, IC cannot change, IC cannot change. तो एक कंडीशन ऐसी आ रही है, IB is increasing because Vin is increasing, but BJT is saturated. ये थक गया है अब. It can provide you maximum current. IC cannot change. IC cannot change. So if this happens, if this at certain point, if this happens, that IC is not changing, but IB is changing and IC is not changing. IB is changing and IC is not changing. Then we can say that IC equal to beta times IB is not valid. अब देखिए क्यों, क्योंकि आप कह रहे हो IB तो इंक्रीज हो रही है. Okay, IB is increasing, but this is not increasing, it is constant. Then we cannot say that IC is always equal to beta times IB. So in fact, in saturation, IC is not equal to beta times IC. Okay, so we can say that when BJT is in saturation, when BJT is in saturation, okay, when BJT is in saturation, beta times IB is in fact greater than IC, because IB और increase हो रही है, IB increase हो रही है, लेकिन IC change नहीं हो रहा है. That means beta times IB will be definitely now higher quantity. तो एक पॉइंट है जहां तक ये रिलेशनशिप हो रही थी फॉलो, IC is equal to beta times IB, लेकिन जब सैचुरेशन आया, अब ये इंक्रीज हो रही है, ये इंक्रीज नहीं हो रहा है. दैट मीन्स दिस क्वांटिटी विल बी हायर देन. इट मीन्स इन सैचुरेशन बीटा टाइम्स IB इज ग्रेटर देन IC. प्लीज नोट इट डाउन. उस्मा, आपको ये समझ में आ रहा है?
Yes, sir.
In saturation, beta times IB is not equal to IC. In fact, it is greater than uh, IC. रेहा, आपको ये समझ में आया?
Yes, sir.
Okay, so then we can rearrange this equation. We can say that IB is greater than IC by beta, or IC is less than beta times IB. These are, just rearrangement of our equation. So in saturation region, please note it down. In saturation region, IC is constant. IC is constant. But IB and IE can change. But IB and IE can change, can increase. And in saturation, please note it down. IC is not equal to IE. जो हम हमेशा कहते थे that IC is nearly equal to IE. Saturation में IC is not equal to IE. But this relationship is still valid. IE is still equal to IB plus IC. It means that when IB is increasing, it is basically increasing IE here. Okay, that is why I say that IB and IE can increase. IB and IE can increase in saturation. Okay, so I'll just graphically draw this operation uh, of a switch diagrammatically. Okay, मैं इसको दिखाऊंगा आपको. Then we may probably stop after some time. So this is my input. This is my input. Just a second. Okay. So this is one plot. This is V input. And this is IC saturation. IC saturation. So I'm plotting my curve input versus IC saturation. So the curve will look like this. I'll then mark this curve. It is like this. So there's a region or a point where V input is greater than VBE when the device tries to turn on, and there is a point when IC is saturated. Okay, IC is saturated. So this is IC saturation level, and there are three regions in this plot: region A, region B, and region C. So region 1, region 2, and region 3 in this plot. In region 1, if you identify or if you observe this region 1, the device is cut off. So it is cut off region of the BJT as a switch. BJT as a switch, cut off region. So in cut off region, IC is nearly zero. So this is cut off region. Okay, this entire is cut off region. This entire is cut off region. This entire is cut off region. So this is cut off region. Okay, yellow one, region 1. So here you will see that IC is nearly equal to 0 because this is IC. This is IC axis. IC तो इसमें बहुत कम है, nearly equal to 0. And there will be another graph which will be V input versus V output at the same time. Okay, तो output में आपका ऐसा होगा graph. It will be like this. Let me draw it. So you have here also you have three regions, 1, 2, and 3. So I'm talking about region now, region A. Okay, and this is VBE point. So when V input is less than VBE, IC is 0 from graph 1. Okay, first graph. From second plot, you can see that VCE is equal to VCC. VCE is equal to VCC. So this is V output, it is VCC. Okay, so this is V output or VCE. So because from second graph, we can see that VCE is equal to VCC. Okay, and BJT is off or it is open circuit, that is in region 1. So our BJT, its equivalent circuit will be like this. So this is emitter, collector and base. इसका जो equivalent circuit बनेगा BJT का वो होगा open circuit. So this is collector, this is emitter and this is base. Okay. Now in region 2, if you observe region 2, if we observe region 2, uh, the region in region 2, it is in saturation. It is a saturation region. Saturation region. Here, IC is constant. Okay, no, it is region 3 basically. Region 3. We'll observe region 3 first. Okay. In region 3, uh, in region 3, it is a saturation region. Okay. IC has reached to the saturation level. IC has reached to the saturation level. While as VCE has reached to minimum value, which is VCE saturation. VCE saturation. So IC has reached to maximum value, VCE has reached to minimum value, saturation values. Okay, so it is saturation region. IC here it is constant. It is constant with respect to VI. If you observe region 3, IC is constant. IC is constant. Okay, IC is constant and it is constant with respect to V input. Similarly, VC is also constant with respect to VE, that is saturation region. So this is region 3. Okay. So IC is constant with respect to V input and it is equal to IC saturation. Similarly, VCE is also equal to VCE saturation and it is nearly equal to 0. And in this region, our BJT is on. Okay, BJT is on and it acts as a short circuit. Short circuit. And when BJT will be on and it acts as a short circuit, this is what will be the internal circuit diagram. So you have BJT like this. So internally it is short circuit. There will be some internal resistance between C and E. So there will be some internal resistance between C and E. C and E. And what will be that resistance equal to? R of on. R on is equal to VCE saturation divided by IC saturation. तो जो resistance between collector and emitter होगी वो होगी बराबर आपकी current की value कितनी है? It is IC saturation and what is the voltage between these 2 points? So it is VC divided by I, because V is equal to IR and R is equal to V divided by I. V divided by I. I'll take attendance and I'll stop after some time. Okay, so that was region 3. Okay, it was region 3. And what about region 2 now? Region 2. In region 2, we know that BJT has a linear relationship with voltage. Current IC has linear relationship, and similarly, voltage also have linear relationship with input. Okay, so region 3 is active region of BJT.
रीजन टू
So, yes,
आपने 3 बोला था तो
अच्छा I'm region 2 मैंने कहा ठीक है region 2. Okay, region 2, we are talking about region 2. So region 2 is somewhere here, this pink one. So this is region 2. So I'm talking about region 2 now, and I said that it is active region. Okay, so in this, if you observe that, IC varies with V input. Here IC varies with V input. Okay, so here BJT is said to be inactive. BJT is said to be active. It is said to be active if its IC is able to change or able to respond to changes in input, So a BJT is said to be in active region when it is able to respond to the changes in the input. I said that BJT is always operated in active region when we have to amplify a signal, because our AC signals are varying signals. So if your BJT is responding to the changes in the input signal, then you say that BJT is operating in the active region. Okay. So BJT is used, BJT is used as amplifier by operating it in active region, active region. Okay. Active region. So I'll conclude that if you have to operate BGT as a switch, then it has to be operated in saturation region. It has to be operated in saturation region. Okay. But if you have to operate it for an as an amplifier, then you have to operate in active region, because in active region it should be able to respond to the changes in the input signal. Okay. Now see, we had a discussion that beta times IB equal to IC is no more valid here. But there is a question then, a golden question would be, what is the beta? What is the current gain in saturation? What is the beta in the saturation region? So beta can be calculated as in saturation region, when beta acts as a saturated, in saturation region, then the beta saturated is also known as बीटा फोर्स्ट. उस टाइम पे बीटा को कहा जाता है बीटा फोर्स्ट या forced beta. So forced beta is basically ratio of IC saturation and IC saturation and IB. IB. So when BJT is in saturation region, so beta forced will be equal to IC saturation divided by IB. And we should note it down that IC saturation is constant and IB in saturation it varies. So beta forced also varies. Beta forced also varies. So there is no single value for forced beta in saturation. It depends upon the value of IB. If Vi is increasing, then we know that IB will also increase. If IB will increase, then beta forced is bound to decrease. Okay. Beta force is bound to decrease. And if it decreases, then how much it decreases from the normal value of beta, actual value of beta, that is measured by a parameter known as overdrive. So overdrive, it is equal to, basically I'll write it down. Overdrive, it is a measure of, it is a measure of level of saturation in the transistor in the BJT. So how much post beta changes from the normal value gives us the measure of level of saturation कि कितनी saturation हुई है इस transistor में इस BJT में, and that is basically measured by a parameter known as overdrive. So overdrive is a measure of level of saturation in BJT, and it is nothing but it is a ratio of active beta. Active beta means actual beta, and forced beta. Okay. So overdrive is the level of saturation. Overdrive, it is equal to beta divided by beta forced. Beta divided by beta forced. So if IB will increase, what will happen to beta forced? Beta forced will decrease. And if beta forced will decrease, then level of saturation will be more. Overdrive will increase. Overdrive will increase. If overdrive is equal to 1, it means it is beginning of saturation. Okay, overdrive. If overdrive value is equal to 1, it means beginning of saturation. If overdrive value is greater than 1, it means transistor is in transistor is in saturation. And if value of overdrive is much higher than 1, it means that transistor is in hard or strong saturation. Transistor is in hard and or strong saturation. Okay, so I'll stop here. If you have any question, you can ask me right now. Roll number 2.